So now we're ready for section 10.4, where we're going to look specifically at average rate of change. Now, we'll obtain this. Another way to think of average rate of change is the word we've used in algebra called slope, the slope of a line segment involving two endpoints. Specifically, that's going to be called a secant line. So when we have two endpoints from a function and we get the slope between those 2 points, the line that connects those 2 points, that's called a secant line. We'll more formally develop that in the next sections. What we're going to do today is we're starting to lay the groundwork. So where we move the 2 points, we take one of the points and we move it closer to the first point until it becomes so close, we think of it as 1 point. That's the slope of a tangent line, slope at a point. It is calculus, it is limits that allow us to do this. So first we're going to go through a little bit of reminders about slope from algebra. So remember our slope, we've got our 2 points, one we label x1, y1, the other x2, y2. Which one is which is kind of a toss-up. You could do either one. We can make this more point to the right. We could have made this x1, y1, and the other x2, y2. Okay, but it's our ratio of the run under the rise. So the rise always goes on top, the run is on the bottom. We're subtracting the two y values divided by the two x values being subtracted. That's what slope is. That's what average rate of change is. Now, with average rate of change, we're not going to talk so much about the line as we will about the line segment. It's the slope of the line segment. So a couple other concrete examples. Here is one with 2 set points. So we've got the point 1, 2 here on the left and 4, 3 on the other. So as you can see, we subtract the x's. So we take 4 minus 1, we get 3. Over here, we're subtracting the y values. 3 minus 2, we're getting 1. So we're getting a positive slope, 1 over 3. So rise of 1, run of 3. We also could describe this line as going uphill, looking from left to right. And we will see that, and hopefully remember, that any line that's going uphill is going to have a positive slope. So it'll have a positive value. Another example, line segments, lines that are going downhill. So from left to right, we're going down, way over there. We do the same thing. It's the ratio of the difference of the y's. We also call this the difference quotient. We subtract the y's in the top, subtract the x's in the bottom, and in this case, we get a slope of -3 over 2. So we rise -3, or we drop 3 and then run 2. That's our slope. Okay, so that's in a nutshell what we'll be doing today. And then the last exercise gets us to move the points closer together. And that's going to form the basis of what we do to get to something called a derivative. Okay, so here's an example from the textbook that we're going to use. And we'll do a few examples with this of calculating the average rate of change between two endpoints, and we'll be changing those endpoints. So here's our data. Okay, so we're just going to look at these next 3 examples where we calculate the average rate of change, the slope, between 2 different endpoints. So the first one we're going to look at 10 and 14. So that'll be this point and this point. So the y values, we'll start with the one that's larger. We could choose either one for y2 we want, but let's go ahead and call 1800 y2. Then we subtract the other y from that, 1150. And in the denominator, we're going to have 14 minus 10. So the y values on the top, the x values on the bottom. We're subtracting them. That's why we call it the difference quotient. They're subtracting, that's the difference. Quotient is a fraction, division. So in the numerator, we get 650. And in the denominator, 14 minus 10 is 4. And when you do that division, you get 162, 162.5. Okay, so we're going to look at the point 8 and 10. Okay, so we'll do the same thing. The y2 we'll call the 1150, and we'll subtract 1400, the second y. So we always start and be consistent. Since we're calling this y2, we'll state 10 minus 8. So when we do the subtraction on top, we're going to come up with a negative number. 1400 minus 1150 will be 250. And in the denominator, 10 minus 8, that's 2, positive 2. And so when we do the division, we get negative 125. So there's our slope. And our units are going to be, the y value is S&P index, so points, and the x value is years, so these are points per year. We'll emphasize that more later, but these are points per year is the units we are dealing with. The last one, let's go ahead and deal with, let's go with violet. Haven't used that recently. So we're going to use 8 and 13. So we'll focus on 8 and then 13. So we'll stick out here with 13. We'll go with the 1400. That matches up with 13 minus 1400. That goes with the 8. Looks like we're going to get 0 on the top. That's okay. 13 minus 8 in the denominator. So that gives us 0 in the numerator, and doesn't really matter all that much, but it's 5 in the denominator, but that gives us a rate of change of 0. So that was a constant. Okay, so 3 different rates of change depending upon which part of the functions we're dealing with. So you can have different rates of change at different times, different years from one year to the next, average rates of change. So the next slide, we want to graph the line segments, sort of the slopes themselves. So I'm going to pull out the line tool. Let's see, what did we use? We used blue for the first one. So going from 10 to 14, so that would be from here until 14. So that's what that slope of positive, what was it, 162.5? That's what that would look like. For the next interval, going from 8 to 10, we did that one in green. So going from 8 to 10, we're going from this point here. So that was a decrease of 125. And then our final, we'll take a look. We were in purple, and we were going from 8 to 13. So we went from this first point here all the way to the 13th year, and that was a constant. It was a straight line across, no change over those time periods. Change in between, we went down and then came up. But from year 8 to 13, if you bought in year 8, sold in year 13, there is no change in those, the value of the S&P. Okay. So again, we'll clear off the screen and we'll move on to the next one. So difference quotient for average rate of change. What we're going to do is expand this a little bit. It's something we've already been using. We've been using y2 minus y1 over x2 minus x1, thinking of the slope. As we move towards a difference quotient, we're going to get something that's more using more function notation. So that's what we get here. And what we're going to want to look at, let me go back to blue, is that f of b is the y value when x is b. So we really got 2 points here. Instead of x1, y1, we're talking about, let's see, match up here. Actually, this would be a f of a. So f of a is a y point. And then the second point we'll talk about as being b, f of b. And that gives us a slope of through the points P and Q. If you want to look at the text, they'll basically call this first one is maybe this, they'll call that one P and this one Q, or it could be the other way around. It's kind of arbitrary. What we're going to do is to get what this is really going to do to empower us is we're going to go from this notation. And what we're going to say is that, you know, A is the first point here on the left side of the graph. B is going to be some point on the right side of the graph. So how can we say what B is in relationship to A? Well, we can say B is just A with something added to it. It's something further away than A. So what we're going to say is that B, in fact, we're going to make it A plus some distance. We'll just call it H. Why H? Why not? That's all I got to say. So we're going to add a little bit to A, and that's what we're going to call B. B is just that next point, however long. And what that does is it allows us to think of that distance as a variable. We can make it smaller and smaller and smaller till we get them to be 1 point. So if we do that, I've got the formula finalized on the next page, but I want to show what happens here. So what we have, not f of b, we have f of a plus h. So what is going to ease us up a bit is a will be a number minus f of a, so that doesn't change, right? In the denominator, though, instead of b, what we end up with is a plus h, because that's what b is, right? So in place of b, we put a plus h, and then we've got minus a. Now, they don't do this step in the book, and I haven't seen it in, I just haven't seen it in another book. But I remember this is the place where it kind of threw off to me, because if you look at what the book has as the difference quotient, it took me years to really match it back up to slope. Look in the denominator, we have a minus a. And I'm sure my teacher told me this, but for some reason it didn't click. A minus a is 0, so in the denominator, all that's left is h. In the top, we have the two y values. But you see, it seems like we're only left with one value in the denominator. That's true. But we started with two of them. It's just that a minus a is 0. So, and again, don't worry too much. We're going to be given this formula on the next page, but I just wanted you to see the steps that get us to go from the slope function that we're familiar with from algebra to having it written in more of a calculus form, which is a difference, the difference quotient for average rate of change using function notation, and then making one of the points, one of the interval, the end interval. So we're going from a to a plus h. We're defining the end of the interval by how far away it is from the start of the interval. You know, it makes sense. How far is that? And we then are going to be able to change just that distance. So we've got one variable that we're changing. Okay, so that's all the magic. And I'm going to show you that once we get going with all of this, there is a nice way to use our calculator technology as well. So here's the alternative form, average rate of change, f over a to a plus h. And they do state that, yeah, they replaced b in the formula with a plus h, but they didn't show it. So I wanted to show it to you. This is what we end up with. This is what we're going to use. But without that middle step, without that step of showing that we had a plus h in the denominator, and that the a minus a became 0, it's difficult to see that this is really just a slope formula, but it is. And now what we're going to do is we're going to change h to be a smaller and smaller and smaller value. Notice in this setting, if we let h be 0, no distance, it's undefined, that's where limit is going to come in. Okay. So now I'm going to show you how to use the technology to actually calculate the limit. We're going to get closer and closer and closer. So what we're going to start with here, and I'm going to show you in two ways. I'm going to show you with the TI-84 calculator first. Then I'm going to refresh myself, but you won't see that. The video will continue. I'm going to show you exactly the same thing with the Casio calculator. So if you're using the Casio calculator, you might want to just fast forward through this till you start seeing me use the Casio calculator. You'll see this slide again, but it will be with the Casio. Okay, and actually, if I move my shoulder, this example with the TI-84. What I do is I'm going to clear everything out so you can see it from the start, and I'm going to clear this out because you need to see how I did this. This will help you with the last, 3 or 4 homework assignments in the WebAssign. So okay, so you can still see that, yeah. So we're going to put this in as y1. So I'm going to arrow up. Just go to y equals if you aren't already there. And in y1, we're going to put that equation. So we'll enter 5. We'll use the variable key, which uses an x instead of a t. That's okay. Raised to the second power. We arrow over. We subtract, not plus, come back here. We subtract 85x. And then we add 1,762. Now, I'm going to show you how to use the table to do this. So I actually don't want this function showing up. I want the difference quotient showing up. So I'm going to come up here, I'm going to go to the equal sign, and I'm going to hit enter. What that does is it unselects it. It will not graph it, and it will not give me the table, because I don't really care so much about the function values as I care about the difference quotient. So now in Y2, I am going to enter the difference quotient. And let's see, what's the difference quotient? So we're going from 8 to 8 plus h. So let me go ahead and write that over here. What are we really doing? So the difference quotient is going to be g of 8 plus h, because that's the endpoint, minus g of 8. And again, it really is 8 plus h minus 8. The 8 minus 8 is 0. So what we're going to put in our calculator is g 8 plus h minus g of 8 over h. And then I'll do it again with the other calculator. So we want to put in a fraction. So we go to alpha f1, and notice we get the setup for a fraction. If you don't, your calculator is older, and what you're going to need to do is put parentheses around the top. Since you only have one thing in the denominator, you don't need to do that, but hopefully you have a new enough one. Now what we want to do is we want to use y1 as our function. We can call it, there's this key here that says vars, like a pirate saying something like vars. I don't know, pirate, where that came from, but it just sounds like a pirate to me. We go to y vars for variables. That's the function, and we want to use function, and we just hit enter, and there's our y variables. So I want to use y1 because that's where I put my function. I'm going to put parentheses, and I'm going to put 8 plus a variable of x. And what I'm going to do, it's kind of hard to see, but in this version, what x is going to be, I'm going to let x be my h. So I'm going to control the x, and since it's plugging 8 plus x into the function into y1, the value here will be that y value. Okay, and then I subtract, again, what the variable I want is vars, y vars, enter for function y1. I want y1, and this one I want at the endpoint 8. So you'll see all of them, they'll give you a starting point, and then the second point is that point plus h, or in this case, plus x. In the denominator, we just put in x. Okay, so that, and then x is going to be our h. Now it will all work because when it refers back to y1, notice this one's going to do y1, it's going to plug in 8, so it'll be the y value when x is 8. This one will be the y value when x is 8 plus whatever x is. Okay, so the other thing we're going to do is we're going to look at the table of values, and then we're going to be able to fill this in. And I'll move this up a little bit here. So what I want is I want my table set. So notice above window it says table set. So I hit blue, table set. I want this to be set up to ask for the independent. So the independent I change from auto to ask. I hit enter. Now notice my independent variable is on ask. So now when I go to this table, I go secant table. There's nothing there, but as soon as I put in an x value, it will fill in the y value. And since for y2, and what's in y2? The difference quotient. What is the role that x is playing in the function y2? It's playing the function of h. It is being h. So what I'm going to do is I'm going to plug in 1. So this first one, it's got nothing, so I just put 1 and watch what happens. It plugs it in, and it's hard to see, but it's 0. So what I can write down here is 0. And then I'm going to put in 0.1. And if you look at the textbook example, you'll see so far, it's right on track. We put in 0.1, and now it's giving us the answer as a fraction. It's negative 9/2. And then I'm going to put in 0.001, and I still get those fractions. And then I'm going to put in 0.0001. I left out 1, didn't I? I jumped too fast. This should be 0.01, just so that you can see the consistency. 0.01, 0.001, and finally 0.000. 1, 2, 3, 1. So that'll be all the values. The only part is I was hoping it would give me decimals, because that's kind of what they want for these. You'll see that each of these should be like, I think it's negative 4.5 up here. There is a way to get that to happen. Let's make it larger. And what we can do is, if I remember correctly, we go to format. So I did secant format, and I'm going to arrow down. Let's see. No, we don't want format. We want to go to mode. So I'm going to hit mode again. Math print is class, or we could be in classic, normal. Let's see, there is one here. Answers, auto or decimal. I can force it to change my answers to always be in decimal. But it's nice, sometimes maybe you do want the fraction. So now when we go back to our table, don't have to change it again. We get our decimals. Okay, and notice this last one it just comes off as -5. If you want to come over here, it's because it had to round it. If you come here, you actually get exact. So sometimes the answer might say to 4 decimal places, 5 decimal places. You're actually going to want to come to the table itself to get those values. Okay, so now I'm going to shrink it back up a little bit. Hopefully this all makes sense. Maybe it would have been better. But the nice thing is now that you've gone through this, when you do your homework, all you have to do is go change y1, whatever function you put in there. y2 you might have to change unless if it's starting at 8, you wouldn't change that part. Sorry, I'm covering up my, there we are. So now we can actually write in these values. So when h is 1, we ended up with a rate of change of 0. When it was 0.1, which means we're getting it close. So we started off 1 apart, and as we got closer, we actually got to a negative slope, 4.5, negative 4.95, negative 4.95, negative 4.995, and negative 4.9995, which we can see if we were to round this, we are getting very, very close to -5. So what we're going to see is that what we did is the point at the slope 8, the instantaneous rate of change, we could say is -5. So we're going down. I said downward at 5, -5. Okay, and but this is what they want for the homework as well. They want you to calculate each of these. Now you could do each of those by hand, but I think you're going to see now that you have it set up, practice that a little bit. It makes it so much smoother once you get it, and you're able to get our table of values right here and see how that works. Okay, so I'm going to run through this one more time, but I'm going to use the Casio calculator. And sorry, oops. Okay, so this version we're going to do with the Casio. And again, we're going to work the same problem, talking about the price of gold, and where T is between 7.5 and 10.5, that this formula works. And we're going to do it over the interval from 8 to 8 plus H. And then we're going to let H be various values, which we'll reveal here in a moment. But what that means is we need to set up the difference quotient. So the difference quotient is going to start with, so our interval, what we're going to be doing is we're going to go from 8 to 8 plus H. So this is we need our Y2 here. And this will be our Y1, right? And so our first function is going to be G, sorry, not F, G of 8 plus H. And then we're going to subtract G of 8. So that's a value we could just plug in. We could calculate it, get those numbers. We could do this all numerically, but what I'm going to show you is how to set it up and kind of automate the process with the graphing calculator. In the denominator, what are we going to end up with? Well, we'll have 8 plus H minus 8. 8 minus 8 is 0, so what's left, remember, is just H. This is the slope of the line between these 2 points. We're going to let H be able to change, and it's going to work like magic. It's really going to be nice for us. So let me click there. Let me bring this here. Where we want to go, and hopefully this looks pretty clear, is we want to go to table. So table is right over here, so we can, it's kind of nice with the, let me clear off the screen. With the menu, but it does take some getting used to. So I'm going to go to the table. In the table, I need to put my first function in here. So I'm going to put in the function we were given. So that's 5x squared minus 85x plus 1762. So we'll put in 5. The x variable's right over here. We're going to square that. Hit to the right, so we come down on the line. We're going to subtract 85x, and then we're going to add 1762. And then I'm going to execute that. And I'm going to come down just to make sure 85t. Yes, that's correct. Okay, so everything so far is good. Now we have something a little easier when we're going to put in for this next function. We want a fraction. That's okay. I'm just going to put an equal, so I start into here. So I put a parentheses. I'm going to put it all in a parentheses. We have this y. So when I click on this, that gives me y. Which one do I want? I want y1. So I go y1. I put another parentheses. Think of this as function value. And what I want to put is my 8 plus x. And now this time my x I'm thinking of, that's the variable I'm going to use is h. So x is standing for h. It's actually a different x than up here. Now what this function is going to do, y1 is going to take 8, add x to it. So when I put in 1, it'll become 9, and that's what it'll plug into this function up here. We're going to subtract, again, y1. So I just put this F1 key. That gives me y1. And I want to subtract that function value at 8. And I close the parentheses off one more time. So the whole numerator is up there. And then I divide it by what? H, which I'm going to use the variable x. Okay, so I've got the whole top divided by x. I'm going to execute that. So now that's in there. And then what I'm going to do is go back to the top, and I'm going to select. And when I select it, actually, since it is selected, see the equal sign is highlighted. I'm going to select it, which actually unselects it. So it won't graph. It won't be there to confuse me. If it was there, it would be as a y1, and hopefully I know that at this point I want the values from y2. Okay. So now it's time to go to our table, and notice table is right over here. It's just this function key. So I'm just going to hit it, and now it's filled in some values for us. It says when x is 1, y is 0, and then x is 2. It's giving us some other values. We don't want x to be 2. We want it to get smaller and smaller. And so, and then I'll let you fill this in. I guess I don't have to actually fill. So what I do is I just arrow down to 2. What I want that to be, I want it to be 0.1. And then I hit the execute key. It puts in 0.1, and now it's negative 4.5. I'm going to arrow down. What do I want to put in? 0.01. Execute. Negative 4.95. So we see how this is going. 0.001. So I'm just filling in, changing the values, and we got negative 4.995. And then I do the last one of 0.0001. And I've got my last value. And again, just like with the TI, if you were watching both, you can arrow over and it gives you an actual values. The nice part about doing this is once you get it set up this way, you can work multiple problems simply by changing the y1. When you go down to y2, if it has a different starting value than 8, you change that 8 to whatever the starting of the interval is. And you're going to get these values because you've got it set up. And I think it will remember them. If not, you may have to enter them in. I know on the TI-84, it remembers them. And so see how you do that. If not, work each one by hand. It's only, 4 or 5 calculations. And it might be helpful to do it for once, but I'll tell you by the second and the third one, you're going to want to set it up this way, and it makes it just so much more automated and nice. But that's our lesson for today. So I'm going to just put that down. It's a little messy, but we'll look at some problems together. We'll go over these with how to use the calculator to do them, how to do them by hand. Whatever questions you have, we'll address them tomorrow in our Zoom class meeting. Thanks.